This is simple cubic structure, right? Simple cubic structure. SC, we call it as SC. So in this red diagram, there you see a kind of this box is drawn in a lighter lines, you see. Okay, so this is 3D, you see. This is one face, if you assume as front face. This is side face, and that is back face. This is top face, this is bottom face, right? So these will form bottom face, these will form top face, these four will form front face, these four will form side space, right? So this is a 3D structure. Can you imagine this structure is actually being here? This line here, this line here, this line here, this line here, this line there, right? This structure is known as simple cubic structure. All right. So now we have 4 plus 4, 8. You know, structure atoms 4/3 pi r cube. All right. If I consider one side of the cube as A, unit volume A, right? Unit volume A. So which means the volume is A into A into A. Is that thing okay? Volume of cube is equal to A height into A length into A, that is width, that is A cube. Is that okay? Similarly, volume of sphere, right? Sphere is this one. So you have seen that is one sphere at all. So 1/8 into 8 pieces. So 1/8 volume into 8 pieces of structure atom. So that is 1 atom. So volume of sphere is 4/3 pi r cube. Now r, you know, this is A, right? This is A for the cuboid. In 1A there is 2 r, right? You see 2 cylinders, 2 sphere parts are here. So I can say this as r and this as r, right? So from there you can say A is equal to 2r, right? Because here one atom, here one atom, 2 atoms making 1A, that is A is equal to 2r. Then r is equal to A by 2, that is 0.5A. Okay. Now I will put this 0.5A into my equation, that is 4/3 pi r cube. R is 0.5A cube. Sir. All right. So I'll substitute this r with 0.5A whole cube, right? So that will give you 4/3 into pi, you know, 22/7 into A cube into 0.5. So 0.5 into 0.5 into 0.5, how much? 0.25, 0.125, 0.125 A cube. All right. Now you see here, one atom into found 1/4 pi A cube. I don't need the exact value, but I just need the ratio, right? So if I divide this with this, that's what happened here. This value is here and this value is here, right? So 4/3 by A cube divided by A cube, that will give you 0.52. So your A cube and A cube will be cancelled, right? At the bottom you have 1. At the top you may have 4/3 into pi into 0.125. 125. So if you substitute, you will have 0.52, right? So here in simple cubic structure, right? In simple cubic structure, the ratio of atoms to the ratio of void space is 0.52. So here in the simple cubic structure, only 0.52% of the volume is filled with atoms, while 0.48 rest of the percentage is empty. All right. Now I am going to introduce you certain terms, right, which is accompanied with this calculation. Now we just have said radius and volume and cube and sphere and all, right? So now I am going to introduce you certain terms which are accompanied with. Here you see APF, atomic packing factor, right? APF we call it shortly, atomic packing factor. This atomic packing factor is given as volume of atoms in unit cell over volume of unit cell. You need to understand the difference between these two. Volume of atoms in unit cell. So that is this atom, this atom, this atom, this atom, this one, this one, this one, and this one. Right. So volume of atoms in unit cell divided by volume of unit cell. Volume of unit cell is this into this into this. This is the volume of unit cell. Right. So this A cube is the volume of unit cell, and here this 4/3 pi r cube is the volume of atoms in unit cell, right? So what you have calculated so far is known as atomic packing factor, right? So atomic packing factor for simple cubic structure is 0.52, right? So while we are calculating, we never go into these names. Now I am introducing the names, right? If I introduce the names by that time, that will be complicated. So what you have calculated as the volume of atoms in unit cell over volume of unit cell is 0.52, which is known as atomic packing factor for simple cubic structures. Okay, we are talking only about simple cubic structure by now. Close pack directions contains 8 into 1 by 8. So this 8 into 1 by 8, we have 1, 2, 3, 4, 5, 6, 7, 8 atoms, right? 8 atoms. They are not total full atom, just 8 atoms, and 1 by 8 of each atom is actually incorporated here. So this particular region is 1/8 the volume of a one sphere, right? Rare due to low packing density. Only PO has this structure. So rare due to low packing factor. So this structure, right, simple cubic structure is existing only on polonium, right? Polonium. Close pack directions are cube edges. Coordination number 6. So this coordination number means an atom, any one of this atom, right? Any one of this atom. It need not to be this atom or that atom or this atom. Any one of this atom forms contact with how many other atoms, right? So if I take this atom, right, this is in contact with this atom, right? These are in touch. This is in contact with this atom. These are in touch. This is in contact with this atom. Okay. And if I place another layer here, oh no. If I place another layer of atoms here, right, this will be in contact with the atom on the top also, right? So this atom also it will be in contact with. And this will be in contact with an atom which is on this side, right? I can draw certain atoms to this side also, right? So this is going to be like this. Throughout this one, I can draw atoms like this. Similar way here also I can draw atoms like this. Downward also atoms I can draw. So this is a continuous structure, okay? Just for the sake of easiness, we take 4 and 4 atoms to explain you, right? So if this red atom, right, this red atom is this atom, if I assume this as this red atom, so this way one, that is this one, right? This white one, that is this one. Top side one, that is this one. This side one, that is this one. This side one, right, in front of the atoms, no. So that is this atom, and in the bottom side one, that is this atom, right? So totally an atom in simple cubic structure can be in contact with 6 atoms, right? I repeat, in simple cubic structure, any arbitrary atom can be in contact with 6 atoms, right? I am talking about contact, so this and this should touch, they should share the surface. This and this are not in contact, right? This and this are not in contact because in between there's a void. You see here and here, that is not contact because there's a void, right? But this and this are in contact. You see here, there's a contact, right? So coordination number is 6 for simple cubic structure, and the meaning of coordination structure is nearest neighbors, or the atoms which are in contact, right? Nearest neighbors or the atoms which are in contact. And usually these distances will be equal for all 6. So this, if I consider this as distance A, this one, here, here, all distance will be A probably, right? So the coordination number is the nearest neighbors which are in contact with each other. So for simple structure, simple cubic structure, the coordination number is